this case study video, we are just going to see about one of the famous problem which is occurred in this subject called as operating system, which we have already discussed in the class. It's nothing but the Dining Philosopher Problem. Here what we are going to do is how we can incorporate this design thinking framework in this subject. Especially I have took this topic called as Dining Philosopher Problem. Let me just explain the scenario so that each one can define the phases of design thinking.
Okay.
Like you know, there are 5 phases in design thinking. Say for example, the first one is empathize, where we can tell the abstract of the or the problem of the topic, and similarly define. We can define the problem, and ideate. We can have the components with what are all the methodologies we can use to solve this problem. And if you take this prototype, and even we have testing. So here the scenario is, we have this problem states that the philosophers are seated around the circular table, and with one chopstick between each pair of philosophers. So there is one chopstick between each philosopher. The condition here is a philosopher may eat if he can, if he can pick up the 2 chopsticks adjacent to him. So one chopstick may be picked up by any one of the adjacent followers, but not both. So this is the given scenario. So let's Harshini will explain the empathize.
So everyone, I'm going to explain about the empathetic aspect of this particular problem. So generally, if we see, the problem is that all the philosophers cannot have the food at the same time, since they are provided with just one chopstick. So ultimately what this leads to, it leads to starvation due to the circular dependencies. Now I give on to Kamachi to explain about the defined part of this problem.
Okay, hi everyone, I'm going to define the problem statement here. So let's take this as an example. So each philosopher has access to only one chopstick, where it is in order to eat they must have at least 2 chopsticks. So they all depends on a circular dependencies. So each one of the philosopher depends on another philosopher for in need of chopsticks. Here where the deadlocks arise. So deadlocks is what makes them to have only one chopstick and prevent them from eating, and it also makes them from starvation. So in order to prevent the deadlock, we find a solution which will be proposed by Arishuddhi and Irfan.
So good afternoon everyone. Today I will be telling you about a methodology which can be used to solve this problem. So as mentioned earlier, deadlock is a situation where each philosopher will have one chopstick each, but we have to have 2 chopsticks to eat. So the thing is, since every philosopher has each of their own chopsticks, the thing is we can perform this condition by using a timer situation. We can perform by time in and time out. So for example, let me take myself as a philosopher, and I have acquired a chopstick as at the initial stage. Now I have to wait indecisively for the other chopstick. What we can do is we can set a timer. So within the time limit, if I can acquire another chopstick from another philosopher, I can eat the food and escape from starvation. And after my timer stops, I can give my chopstick and also the other chopstick to the other philosopher to eat the food. So this is one of the methodology. The second methodology will be said by.
So good afternoon everyone, myself Irfan Ahmed, and I am going to provide a solution which eliminates deadlock as well as circular dependencies. So the method is called as resource hierarchy. So what resource hierarchy does is, for example, if we take this as a chopstick and I will number it as 1, then other chopstick will be numbered as 2, 3, 4, 5. And what else the philosopher do is, a philosopher who is standing here will take the chopstick in the lower number prioritized wise. So the person, as Janila is standing here, she will take 1 and 2, then followed by 3 and 4. Harshini will take 3 and 4.
So it will be in hierarchical order.
hierarchical order, so that it will eliminate both deadlock as well as circular dependency.
So the main problem arise here is deadlock.
Deadlock.
So you are giving a solution for
how to overcome
this.
So in my methodology, only deadlocks will be eliminated, but in his methodology,
both the circular dependencies as well as deadlock will be eliminated.
Okay. So the conclusion here is, even though deadlock arises, we have a solution called as what is that solution?
Resource
hierarchy.
And time out.
And time out.
Okay. Thank you.
thank you.